my name is Stella Viachika. Today I'm going to demonstrate to you how to analyze for microorganisms in a food sample, particularly a liquid sample. I'll also demonstrate two techniques, that is the power plate technique and the surface spread technique. Some people call it spread plating technique. We're going to do two tests, that is the total plate count, where we shall use plate count agar, and the other technique is the surface plating or surface spreading technique, where we're going to use potato dextrose agar acidified with 1% lactic acid, and we shall be enumerating or looking out for yeasts and molds. So to begin with, we make sure that we work under aseptic conditions. All the reagents or materials that I'm going to use here have been sterilized prior to use. We are going to use disposable Petri dishes. These come when they're already sterilized from the manufacturer. So I swab the area, the surface I'm going to work on, using 70% ethanol. Okay. So before you open the juice sample, you swab it also with the same disinfectant to make sure that we don't have any contamination coming from the outer part of the sample. So you shake this thoroughly to ensure that the sample is homogeneous. Okay? So I quickly pass it over the flame. And we also work very close to the flame to avoid any form of contamination. Okay? So I'll adjust my pipette to 1 ml. So I'm going to pick 1 ml of the sample. Okay. And then I'm going to put it in 9 ml of the sterile diluent. So as you deliver this, you ensure that the tip of the pipette does not touch the liquid inside. Okay? So I can discard that. Close this. Make sure I shake thoroughly. If you have a vortex, you could vortex for about 5 to 10 seconds. So this is going to be my 1 out of 10 or the -1 dilution. So this original sample has been diluted 10 times. Okay? So from here, I'll make my second dilution. I'll pick 1 ml of the sample. Okay? And then I'll deliver it. You work close to a flame to avoid any form of contamination. Shake this thoroughly. If you have a vortex for about 5 to 10 seconds. Okay, so I have my 10 to the power 0 or the neat sample that has not been diluted. I have my 10 to the power -1 or 1 out of 10. I have 10 to the power -2. So here the sample has been diluted 10 times. Here the sample has been diluted 100 times. So if I continue diluting the sample, picking 1 ml and putting it in the next bottle, I'm going to have a serial dilution. The serial dilution can be done as far as 10 to the power -8, 10 to the power -9. It depends on the history of the sample. If you suspect that the sample is highly contaminated, maybe if it is juice that is not pasteurized, you can make your serial dilutions as far as 10 to the power -8 or even 9. If you're working with fermented foods, usually use high dilutions. If you're working with a juice that has been pasteurized, any food that has been canned, you may actually not have to do serial dilutions because such samples are more or less sterile because you will not be diluting anything. So I will continue very fast. So before you pick this, okay, pick 1 ml, cover. You make sure the tip does not touch the liquid. Okay, that is 10 to the power -3. Okay. I'll pick from here. Okay. And deliver it here. You keep changing the tips that you're using because you don't want to contaminate the diluent where you're delivering the inoculum. So you pick 1 ml from here, okay, and deliver it there. Okay, so for this particular sample, I've decided to dilute up to 10 to the power negative 5 because I don't really expect it to be highly contaminated. Okay, so after having done that, I am going to choose any 3 dilutions that I'm going to plate. I could decide to plate all these, but it will require so many petri dishes and a lot of media. So I'm going to choose any 3 dilutions and I'm going to plate them in duplicates. So after having finished the cereal dilutions, now I'm going to demonstrate the pour plate technique. You start by labeling your petri dishes, and you have to have known which 3 dilutions you're going to use. So in this case, I'm going to use the 10 to the power 0, that's the sample itself. I'm going to use the 10 to the power negative 3. I'm also going to use 10 to the power negative 5. So on the petri dishes, I have to indicate those dilutions. You, on the other hand, may decide to use any other set of dilutions. Okay, the dilutions that we use do not really matter in terms of the final concentration of microorganisms. They'll still give you the same log value, but it's how easy will it be for you to count the microorganisms. If there are very many in the sample and you use the low dilutions, you'll have a lot of growth on your plate and you'll not be able to count. So in this case, I'll label my plate A and then plate B, plate A and B, A and B. So on this one, I'll put 10 to the power 0, 10 to the power 0. Remember, it's the same dilution, but we are going to work in duplicates. Then I'll put 10 to the power negative 3, 10 to the power negative 3, 10 to the power negative 5, 10 to the power negative 5. So I have put the replicate A and B. I have put the dilution. Then I'm also going to put the test that I'm doing, which is the TPC. Okay? TPC means total plate count. TPC. You could also put the date. You have to put as much information to help you differentiate your plates at the end of the day. So having done that, and also you notice when you label at the bottom or on the side of the petri dish, never the cover. After labeling the petri dishes, we turn them upright. And now we are going to put 1 ml of the inoculum. Inoculum is now the liquid inside the sample plus the diluent that was in. 1 ml onto each of the petri dishes. Remember to use sterile tips. So remember, this was the 10 to the power negative 5. Shake it a bit, okay? And then I'll pick 1 ml and put it on the plate that I labeled 10 to the power negative 5. So you notice as when I open the petri dish, it's just at an angle to prevent contamination. Deliver the 1 ml, okay? Since it's the same dilution, I can use the same pipette tip and deliver the inoculum, okay? So you notice that among the dilutions that I have plated, I have the diluted sample, but I've also chosen to plate the sample itself because I told you about the history of the sample. This particular sample was pasteurized. So it's important for me to include the sample itself among my dilutions, or among my dilutions, just in case the concentration of microorganisms in the original sample was too low. Okay, what I mean is, if for instance the sample has very few microorganisms and I carry out the serial dilutions, I may actually be diluting nothing after the first dilution, after the second dilution. So it is important that we also plate the sample in case we don't have any growth on these other dilutions, the 10 to the power minus 3, the 10 to the power negative 5. I should be able to get something in the sample itself. If I still don't get counts in the sample itself, then I can have confidence that the sample had a very low concentration of microorganisms or was actually sterile. So we pick up already prepared agar from the water bath. We put it in the water bath to cool, because when we pick it from the autoclave, that's usually at a very high temperature, above 100 degrees. So make sure that you wipe the bottle to remove any water that could drip into our petri dishes. So now we're going to pour about 20 mils of the molten agar onto the petri dishes. We quickly pass the mouth over the flame. So we open the petri dish slightly, add about 20 mils. 20 mils is, you pour the agar, when it reaches all the sides of the petri dish, that's about 20 mils. You may add a little more, okay? For this step, we try to be fast to avoid contamination. I know I'm speaking, but ideally you shouldn't be speaking because the medium we're using is non-selective. Okay, so we pour. Okay. So we make sure that we mix the inoculum and the agar. I could do anti-clockwise 7 or more times. Then I do clockwise. Then I can do north-south. 7 or more times is sufficient. Okay. So the important thing, you have to make sure that the agar and the inoculum have mixed very well. You could also do letter M if you want, forward and back, okay, to ensure that the two are well mixed. So we can leave this on the bench for about 10 minutes. The agar will solidify. This agar can be put back in the water bath to prevent it from solidifying, especially if you have other samples to work with. Okay, so next I'm going to demonstrate the surface spreading. As some people call it surface plating or spread plate technique. So with this one, we already use pre-poured agar plates. So we already have our potato dextrose agar on the petri dish, and it has solidified. I think you can see the agar already in the petri dish. So like we did in the previous technique, we have to label our petri dishes. Although before we do that, we're going to choose 3 dilutions to work with. In this case, I'm going to go with the sample itself. I'll use the -1, and I'll also use the -3. Like I mentioned before, the choice of dilutions depends on the history of the sample. It depends on your experience, having worked with a certain group of samples. So you can easily know, or I could say guess, the samples that will give you plates with countable colonies. So again, I'll label plate A and B, like we did earlier. Okay, so here I'll consider the 10 to the power 0, 10 negative 1, and then 10 negative 3. Okay, so we turn them upright. So in this case, instead of 1 mil, I'm going to put 0.1 mil. Okay. And this I am going to put on the center of the agar. so next we have to spread the inoculum evenly on the surface of the agar. So using my metallic rod or spreader, I insert it in absolute ethanol or concentrated ethanol and quickly pass it over the flame and allow it to burn. Okay, after it has finished burning, close to the flame, I'm not going to spread directly. I'm going to first cool it on the agar surface. Okay, you let it touch any part of the agar that is free of the inoculum such that it can cool. But you also make sure not to overexpose the petri dish to air. Okay, you may change different parts of the agar surface just to ensure that the rod is cool. Okay, having done that, then I can spread the inoculum. So you make sure you're close to the flame, and then you keep turning. You notice this finger of mine keeps rotating the petri dish. Okay, so you make sure that the inoculum is evenly distributed on the surface of the agar. Okay. So after spreading our plates, we'll look at the ones where we did the pour plate. See, they have already solidified. The agar has solidified. So what we do, we also stack them together and invert them. Okay, we invert them. For the ones where we've put the eastern molds, we shall not invert them. Then, from this step, we take the plates to the incubator. The TPC plates will be incubated at 30 degrees for 24 hours, but it could go up to 72 hours depending on the growth. If after 24 hours the colonies are there but too small, we can give them an additional 18 to 24 hours or even an additional 48 hours. For the yeasts and molds, we are going to incubate at 30 degrees for 72 hours. Alternatively, you could incubate at room temperature, which is about 25 degrees for 5 days, 5 to 7 days. Okay, so we're now going to put plates in the incubator at 30 degrees for first 24 hours for the total plate count, but the time could increase to 48 or even 72 hours. For the yeast and molds, still the same temperature, 30 degrees for 72 hours.